Okay, in this video, we're going to finish writing the can partition function, and what I mean by that is we're gonna set it up such that that we have to. So for our induction to work that we talked about earlier, we're going to have to set up our arrays, our functions, so that we have the total of. We have to first find the total of the array. So an example in line 9, we have to know the total sum. We have to find that. And then we have to divide that total sum by 2 because the array has to be partitioned where both sides are equal. And so you have to divide by 2 to make it into two subsets such that the sum is the same. So we're going to do that, and we're going to set up the boilerplate for the recursive call, the recursive helper function to partition, so that that can use the induction step that we talked about. Okay, so we're going to begin, and so the first thing that we can do is we can comment out the stub, since we don't need that anymore, and so we can find can partition, and it takes an array, and so now the first thing that we have to do is find the target of the array for each subset. And so what is the total sum of the array? So total is equal to, we could use the built-in Python sum function. And then we can, we know the target is going to be equal to this whole divided by 2. Okay, and so if we look at our test, we see that if the array, if we look at the test in line 39, if the array is less than length 2, so smaller than 2, then we know that we're going to produce false. Because if you have one element or less than in your array, then you have to produce. There's no way you can break it into two subsets with the sum equal. So if length of the array is less than 2, you return false. Okay. So now, now we have everything that we need to set up our partition helper. So that's going to help us solve the inductive case for actually the whole recursive, all the recursive calls and all the mathematical induction that we need to solve this problem. So if you remember from a few videos ago, we talked about, like if you look at example 9, we made a decision. We looked at the right side of the array. We were trying to figure out if we should take 5 or not. And what we noticed that if we take 5 or we don't take 5, what happens is that we get the smaller problem of 1, 5, 11 in line 9, and also the target sum changes. So if we take the 5 in line 11 on the right in our subset that we're keeping track of, then our target sum that we need to hit for the rest of the elements is 6, and the elements that we have to figure out if those can be made into a subset that equals 6 is 11, 5, and 1. So if we think about it, we have, so in this case, we're going to have to return the result of our partition helper, which takes an array. We're going to start at the right end. So an array is described by the array itself and the index that you're at. So let's see. Actually, let's just we're going to start at the last element. So that's length array minus 1, and we have our target. So that's where we're starting our problem. So we have this, and now we have to write a partition helper. So let's go ahead and write all these sort of the specs and tests that we need for the partition helper. So we have to wish for this. We wish for a partition helper, so we're going to write out the specs. So so partition. So let's write out the function signature. I was always taught to write comments such that if the person that's going to maintain your code is a psychopath and they know where you live, so if they can't figure it out, you're in trouble. So that's why it's always good to write good, clean comments. So partition helper, it's going to take an array, naturals, array of natural. It's going to take the array index, and it's going to take a number, a natural, which is going to be the target, and it's going to return a boolean. And the purpose for this is find out if array can be partitioned to equal a particular number. This will be done by seeing if we should take the last element. So we're kind of laying out how we're going to do our inductive step in this kind of dynamic programming memoization kind of way. And so let's write a stub for this function. And the stub is it takes the index that we're starting and it takes the target. And right now, since it's a stub, we're going to return false because we have to test. We have to check if our tests are well formed. So we have to write tests for this partition helper. So let's do that. And we can do a lot of the same tests that we've seen before. But this time we're going to have to provide an extra argument because we have to provide, well, two extra arguments. The element that we're looking at the array and the target value. So since we're starting at the end, we have to send the index of the last element of the array in our calls to our test. So self-dot. Oops. And it's gonna let's use the same example in line 49. So 1, 5, 11, 5, and since this we have to send the length of the array. It's -1 as our second argument. So this is going to be 3, and then the target sum that we're trying to hit in this example for each subset is going to be 11, and we want to return true because this array can be broken into 2. So let's write another test. Let's just take the same one, and suppose we took the first 5, and so 1, 5, 11, and now the index that we're going to start at is 2, and the target sum is actually going to be 4.5 because the total is 9. Sorry. Actually, so this is 11 plus 16, 17. So it's going to be 8.5. And this, we know we can't hit that. So we say this is false. So let's write one more test. Sometimes I have a hard time spelling partition. And let's write partition helper. And the array is going to be 2, 3, 3, 4. And we're going to start at the index 3, which is the last index of the array. And the target sum that we're trying to hit in each subset is 6. And in this example, it's true. We can do that. So let's see if we have the parentheses. It seems like it. And so let's save this. Let's run our test to see if they're well formed. So if we look at partition test, so our first failing test is from the can partition test in line 48. Our second failing test that we show is, it talks about line 57, and it seems like it's a false equals true. So it seems like these tests are probably well formed. And now that we have well-formed tests, we can figure out how to write this function. So let's talk about a little bit about writing this function. So what we're going to see in the next video is that it's not, so right now it may not be clear how you're going to go about writing this function, but we're going to think about things in terms of the ladder of abstraction that we talked about earlier. And recall that I was talking about how when you arrive at a new city, to learn about the city, you can walk around. Another way is to sit in your hotel and look at a map, or you can do both. You can use like walking around and a map to get a very deeper sense of what the city is and what it means, and you can learn about it faster. And so the same way, what we're going to do in the next section to code this function, which is non-trivial, is we're gonna like look at it from a higher view. We're going to look at it from a map view, and we're going to see how we can, by stepping away, it'll give us some insight on where to go in terms of designing our function. So when we walk, which is like the coding, it'll be much easier because we have a better idea of what to do.